Horsey here. Now I'll be going over the solutions to the 2023 paper in some detail, so this will be a fairly long video. To help you find the particular question you're interested in, I've created headings for each question. If you slide along the timeline below the video, you should see these headings and hence locate the particular solution you want to look at. So let's begin the solutions. So here's question 1, and we're faced with a triangle PQR, told the coordinates of the 3 vertices, and in part A we're asked to find the equation of the altitude from P. So let's look at a larger picture of that diagram. There's the altitude from P, and because it's an altitude, it means that it's at right angles to the opposite side, passes through P and it's at right angles to QR, and that's the line whose equation we're trying to find. So let's put the information on that diagram. Always helps to have a working diagram in a question like this. So P is 5, -1, Q is -2, 8, and R is 13, 3. Now I feel a bit disorientated here because I'm not sure where the origin and the axes are. So let's have a look at this. Let's take the x coordinates first. There's -2 and 5, and I'm looking for 0. So -2 to 5, 0 must be around about there. So if I draw a perpendicular line down to about there, and we'll call that be approximately there, that's the y-axis. Let's do the same for the x-axis, and that's at a height of y equals 0. So let's look at the various y coordinates. There's 3, there's -1, so 3 height, -1. I would reckon maybe about there for the x-axis. So that's the x and the y-axis. So there's the origin, roughly there. That's x and that's y. So at least we've got our bearings now. So let's first of all establish equation of a straight line formula. If you remember that, y minus b equals mx minus a, where m's the gradient and ab is the point that lies on the line. You might have learned it with a y1 and an x1 in there, point x1, y1. So that's the equation. We need to know gradients, and remember, to find gradient we're talking about the difference of the y coordinates divided by the difference of the x coordinates. So that's rise over run, as it's sometimes called. We also will find a perpendicular gradient, and we know that if you have a gradient and you multiply it by a line the gradient of a line perpendicular to that one, then you get -1, and that involves then, if we divide both sides by m, this is where you turn the gradient upside down and change the sign. So there's that going on. So let's first of all, then, this is part A that we're having a look at. Let's first of all find the gradient of QR, and then we'll be able to work out the gradient of the altitude. So the gradient of QR, that would be the y difference. Now let's start with this 8 and subtract this 3. So 8 minus 3, that's the y difference, over the x difference, -2 minus 13. -2 minus 13. And it's as well thinking at this stage, since that line goes downhill, this gradient will be negative. So 8 minus 3 is 5. -2 and another -13 would be -15. So the answer is negative. 5 cancels and we get -1/3. That would basically mean you go along 3 units, you've gone down 1 unit. That looks okay. So what does that mean for the gradient of a line that's perpendicular to that? Well, that implies that a perpendicular gradient, and that's using this result up here, would be turn this upside down. So instead of 1 over 3, we get 3 over 1, and then change the sign. Well, that goes from negative to positive. And you can always check that the product of these two is always negative 1. That's the result with perpendicular gradient. So the gradient of the perpendicular is 3. And that's fair enough. 1 along 3 up, 1 along 3 up. So quite a steep positive gradient. So what do we need then to use this? We need to know a point on the line. So a point on the altitude is, well, there it is, 5, -1. And just summarising the information that we're going to now be using, the gradient is, well, that's what we've just worked out as 3. So we're in a state where we can work out the equation. So the equation of that altitude is y minus the y coordinate, that's the b, the y coordinate of this point, -1. That's y minus -1, that'll be y plus 1, equals m, that's the gradient, which we're saying is 3, x minus the x coordinate of the point that's on the line, and that's 5. So it's x minus 5. So there's the equation, which needs now to be tidied up. So we have y plus 1, multiply out the brackets, 3x minus 15, subtract 1 from both sides, we get y equals 3x minus 16. And there's another check you can do. Remember the formula y equals mx plus c, that form of the equation. M's the gradient, in this case there it is 3, which we know, and plus c is where that line crosses the y-axis. And in this case, minus 16, well, if we follow that dotted line way down, certainly it will cross the y-axis at a fairly large negative number. So everything ties up. So there is the equation of that altitude. So let's look at part B, and let's do that over here. Now we have to calculate the angle that the side PR, there it is, makes with the positive direction of the x-axis. Now if we look at that line PR and the x-axis, and let's call that theta. Now the gradient of a line, remember, is the distance. If we draw a wee triangle there, it's the distance up or down divided by the distance along, the y difference over the x difference, rise over run. And in this little triangle that we've got, the tangent of this angle, opposite over adjacent. So the tangent of theta, that's the angle it makes with the x-axis, is equal to the gradient. So in this case, the tangent of the angle it makes with the x-axis will be equal to whatever the gradient of PR is. And we can work that out again using this y difference over x difference. So let's do 3 minus -1. Remember, when you're doing these differences, if you start with one point, then you must use that as a starting point for both the differences. So 3 minus -1, 13 minus 5 for the difference of the two x coordinates. So that's 4, 3 plus 1, 4 over 8. That's 1/2. That looks okay. 2 along, 1 up, 2 along, 1 up. That would be a gradient of 1/2. So we're basically now looking for the angle whose tangent is a half. Therefore, we would do our tan to the minus 1 to get rid of this. Tan to the remember tan to the minus 1 can be read as theta is the angle whose tangent is 1/2. So we need a calculator for this. So here we are. And you need to take note of what your calculator is measuring angles in. I've got this set up for degrees. There's radians, so just check the mode that your calculator is in. And tan to the minus 1/2. And my calculator, that's arctan or atan. Yours it will probably be tan to the minus 1, which is the most common one. So the angle whose tangent is 1/2 is equal to, and there's the answer. So it's equal to 26.56 and so on. And that's measured in degrees. So that's approximately 26.6 degrees to 1 decimal place. So this is question 2, and we're asked to find the equation of the tangent to this curve at the point where x equals 1. Now the tangent to a curve will touch the curve at one point. So a straight line touching the curve at one particular point. And to find the equation of a straight line, remember we usually use y minus b equals mx minus a, where m is the gradient and ab is a point on the line. So there's two things we have to find. We have to actually find the point that's on this tangent, and we have to find the gradient of that tangent. So point on tangent. Now we know the point that's on the tangent is also the point that's on this curve. There's its formula when x equals 1. So to get the point on the tangent, we'll put x equals 1 into this formula to find the y coordinate. So it's 2 times 1 to the power 5 minus 3 times 1. Well, that's 2 minus 3, that's negative 1. So we've found a point on the straight line, on the tangent, 1, negative 1. So the second problem now is to find the gradient of the tangent. Now, this curve, we have a formula for it. We can work out the formula that gives us the gradient at any point in this line. And what we do is differentiate this formula. So y equals 2x to the power 5 minus 3x will mean that the gradient formula, dy by dx, will be, remember the rule, 5 times the 2 is 10, bring that power down and multiply, take 1 away from the power, so it's 10x to the power 4, and a term like minus 3x will just give us minus 3. So that's, if you like, the gradient formula. Anywhere on the curve you plug in an x value, you'll find the gradient at that point. Now the point we're at has x equal 1. So when x equals 1 at that particular place on the curve, when x equals 1, the gradient dy by dx will be 10 times 1 to the power 4 minus 3. So 1 to the power 4 is 1, 10 times 1 is 10. 10 minus 3 is 7. So we're now in a state where we can use this formula to find the equation of the tangent. So that's the last stage. So the point on the tangent we've worked out is 1, negative 1. This is what we'll be using. The gradient of the tangent is 7. So that's the formula we use. So the equation of the tangent is, so it's y minus b is the y coordinate of the point on the line. So that's the negative 1. So it's y minus negative 1 equals m, the gradient, that's 7, times x minus a. Now, a is the x coordinate of the point that's on the curve, on the line. So that's x equals 1. So that's the equation. Of course, it needs simplified. Take away negative 1, we're adding 1. Let's get rid of the brackets. We get 7x minus 7. And let's subtract 1 from both sides. So that gives us y equals 7x minus 8. So that's the equation of the tangent to this curve at that point. So here we have question 3, and it's an integration, sometimes called a special integral, because of the nature of the angle here. Now, what do we know about integrating? Well, we know that if we integrate cos x, we get sin x plus a constant. But it's not an x we've got here. We've got a number multiplying x and we've got a number adding. Let's tackle a number times x. So if we're looking at cosine ax dx. Now you do have information on your formula sheet about this one. And here it is. So this tells us that we can go ahead with that integration and we'll get the sine of the angle, which this time is ax, but we now have to divide by that number that is multiplying the angle. So it's 1 over a, or divide by a, plus a constant. So that's certainly part of the way to what we're doing. Now, if we're adding a number also inside that angle, this is like an audience member. It just watches proceedings and sits there, doesn't take any further part. The same is true for a number at the front. So if we're integrating 7 lots of cos 4x plus pi upon 3, we know we're going to get a sine. We know that that is part of the audience. It's not going to have any effect on it. Neither is that 7. It just sits there. The 4 takes an active part in proceedings. That's the number multiplying the angle x, or the x term, and we divide by that. Remember, we have to add a constant. So that's a perfectly healthy way of writing it, or we could proceed and just write 7 over 4 lots of sine 4x plus pi upon 3 plus the constant. So either of these two versions would be perfectly adequate. But that's a slight extension of this little formula here, where the coefficient of x, you must divide by it if you're integrating. Adding a constant, no effect, it just sits there. Multiplying at the front by a constant, no effect, it just sits there and watches everything. Well, here's question 4. We're given this diagram which shows a cubic graph y equals f of x. That's its equation. And it has stationary points at 2, 0 and 0, negative 2. And we're asked on the diagram in our answer booklet to sketch the graph y equals 2 lots of f of negative x. So let's first of all look at the diagram that we've to work with, and let's remind ourselves how these graphs work. For instance, if 1 goes in place of x, the function looks at that 1, does its calculation, and sends out, in this case, let's look at the height of the graph when x is 1, it's negative 1. So 1 goes in, f sees the 1, does a calculation with that 1, and out pops negative 1 as its answer. If we put 0 in, f looks at the 0, does its calculation, out pops negative 2. That's the height of the graph at that point. Now let's consider this function, f of negative x. And this time, if we put 2 in, the function f looks at that and says, oh, you've put a negative 2 in. So instead of over here, it'll be working away over here. That's on the mirror image side of the y-axis. If we put a 1 in, for instance, the function f thinks we've put a negative 1 in, and it'll give us an answer of 0. In other words, when we're here, we get this result. And therefore, we're looking at a mirror image, a flip of this graph in the y-axis. So let's see that. There we go. So we've flipped the black graph in the y-axis to get that green graph, which has a equation y equals f of negative x. So there's the first stage, and it crosses at 1, 0, whereas the other one crossed at negative 1, 0. It has a turning point not at 2, 0, a stationary point not at 2, 0, but at negative 2, 0, and the other turning point at 0, negative 2, as before, because that's still on the y-axis. So there's the first graph. Now, we're asked to sketch a graph of twice this. So the y-coordinates are twice those of the green graph. So in other words, where we have, for instance, let's take negative 3. It looks very much like we've got negative 2 as the height on the graph. If we double that, we'll get a point down here at negative 4. If we've got a point here on the green graph at negative 2, doubling that should give us negative 4. If we've got a point at negative 1 on the green graph, that's a height of about negative 1, double that, we're down there, negative 2. So this green graph is being stretched in the y-axis direction by a factor of 2. Now it will not affect points on the x-axis. That height is 0, double 0, it's still 0. That height is 0, double 0 is still 0. So these points will still appear on the graph of y equals 2 f of negative x. So stretching the green graph by a factor of 2 in the y-axis direction, and there's the graph that is produced. So it passes through negative 2, 0, it's still got a maximum there. It crosses the x-axis at 1, 0, and crosses the y-axis now, 0, negative 4. So that red graph is y equals twice f of negative x. So here's question 5. We're given a function f, which is defined by this formula here, and we have to calculate the rate of change of f when x equals 4. So first of all, You should remember that rate of change just means differentiate. So we have to differentiate this. Now we have an expression raised to the power 4. And there is a power rule when we differentiate, that we take the power down to the front and take 1 away from the power. Now that's our usual power rule. And it works if we've just got an x in there. However, if we don't have an x in there, we've got something a bit more complicated, then we need to consider an adjustment to this formula, and it means we have to differentiate whatever is inside this bracket. So there's that adjustment is added. This is what's known as the chain rule. So let's start and write down this expression. So as we've said, let's differentiate, bring the 4 down, take 1 away from the 4. Remember, this isn't an x, so there's going to be an adjustment, and to get that adjustment we need to differentiate 3 minus 2x. So the 3 disappears, a term number times x, just the number remains. So the adjustment in this case is times -2. So that's our chain rule. Normal power rule times an adjustment which comes from differentiating the thing that isn't an x, the thing that's pretending to be an x, if you like. So let's simplify this. 4 times this times -2. Now 4 times -2 is -8, so there's going to be a -8 outside that bracket, cubed. And that's our final rate of change formula. Now we're asked to find that rate of change when x equals 4. So that's a case of plugging in 4. So when x equals 4, f dashed of 4 is equal to -8 times 3 minus 2 times 4 cubed. So that's -8 times, now 3 times 3 minus 8 is -5 cubed. And we can use our calculator for this, but let's go ahead with it. 5 hours 25, 5 25 is 125. And that's going to be negative, and 8 times that is 1000. Now you check that on your calculator. So the rate of change of f when x equals 4 is 1000. Here we have question 6, and we're given a function f of x, and it's defined by this formula, 2 over x plus 3, and we have to find the inverse function. Now there's a couple of ways of doing this. So let's look at method 1. This one will assume that we put x into the function, we do all the wee calculations with x, and out pops y. Now what does an inverse function do? Well, it puts the y into the inverse function, and it does the reverse, and out pops x. So basically, if we're sitting looking at a formula that tells us how to find y when x goes in, we want to end up with a formula that tells us how to find x when y goes in. In other words, with a formula here, we want to change the subject of this formula to x, not y. We'll do the inverse process. So let's try and do that. Let's take 3 from both sides first of all. Now let's multiply both sides by x, so we'll get x times the whole of y minus 3 equals, and that x is gone. And then to get x on its own, we get rid of this multiplying by y minus 3. Do the opposite is divide by y minus 3. So we divide both sides by y minus 3. So this disappears and we get 2 over y minus 3. So this tells us how to get back to x if we put y in. It's telling us the inverse function. If you put y in, you do all this, and you'll get back to x. Now that's not normally the way we describe a function. We normally describe a function by putting x in. So we just change all the y's to x's. And that's a normal way that we define a function, by means of using an x variable there. So there's the first way of doing it. Let's have a look at the second method. And that would involve starting with x, putting x into the inverse function, getting the number that comes out, putting it back into f, and you'll be back where you started. It's the fact that f to the minus 1 and f undo each other. So that's stated in this way. Put x into one of them, the number you get out, put that back in, and you'll be back where you started. Now, what does the function f do when you put x in? It goes 2 over x plus 3. So if you put f to the minus 1x in, you will get 2 over f to the minus 1x plus 3. Anything that goes into f, let's put that up here, squiggle goes into f, 2 over squiggle plus 3. In this case, squiggle is f to the minus 1 over x. So you get 2 over f to the minus 1 over x plus 3. That's the pattern for what f does when you put something into it. So that gives us x. So let's try and work out what f to the minus 1 of x is. We take 3 from both sides. Multiply both sides by f to the minus 1 x, so that'll appear outside brackets here. And then in this case we want to get rid of the times x minus 3, so we'll divide both sides by x minus 3. We'll be left with f to the minus 1 of x. Let's write it the normal way around. F to the minus 1 of x is 2 over x minus 3. And thank goodness we got exactly what we got the last time. Otherwise, one of the methods would have been wrong. So there's 2 choices for you. So here we have question 7. And you're given this trig equation and asked to solve it. Now, if we're examining this trig equation, you'll notice on the left-hand side we have a sine, and on the right-hand side we have a cosine, but it's not a straightforward cosine. It's a cos double angle 2x. Now, we do have formulae for double angle, and they're given to you in your exam on the formula sheet, and there's 3 different versions. Now, we certainly don't want to make life too complicated for us, so because we have a sine on the left hand side, it would seem daft to introduce a cosine and a sine, or daft to introduce a cosine. I think this third version, where we've still got a sine and nothing else, would be a useful substitution for this cos 2x. So let's do that. So we'll try replace cos 2x by this version, 1 minus 2. Now it's not sine squared a because the angle is x. So sine squared x degrees. Let's get rid of the brackets. So 3 minus 6 sine squared x. Now, you might be beginning to suspect, let's look at an equation similar to this. If you had an equation like this, I hope you'd recognize this as being a quadratic equation, and you try and get everything on the left hand side equal to 0, and for a quadratic you'd try and factorize it, or if it didn't factorize, use the quadratic formula and so on. So let's try and get everything onto the left hand side, and we'll do that by adding 6 sine squared x to both sides. That sine x is still there. The plus 2 is still there, but we'll get rid of this 3 by subtracting 3 from both sides. So 2 minus 3 is negative 1. So on the right hand side, because we've subtracted 3, that's gone, and because we've added 6 sine squared x on both sides, this is also gone. We've got 0 left. So there we have a quadratic equation. 6x squared, normally it would be this, but instead of x we've got a sine x, and you would normally try and factorize that, maybe put 2x, 3x, no choice for the last one, and you'd have a look at the insides and outsides and see what was going on. Now the outsides have a 2x, the inside 2 multiply to give us 3x. And to get a plus 1x, you would have a plus 3x minus the 2x. So that inside 2 would be positive, the outside 2 multiplied would be negative. And that's it factorized. So let's just replace, instead of x, we've got a sine x. Let's just replace this result by the same thing with a sine x in there. So it's 2 sine x plus 1. And this factor is 3 sine x minus 1. Now what do we do at this stage? Well, we've a couple of factors multiplied give us 0. One or other of them is 0. So either 2 sine x plus 1 is 0, or 3 sine x minus 1 is 0. So if the first one was true, we'd have 2 sine x would be minus 1, and therefore sine x divided by 2 at that stage would be negative 1 over 2, so negative 1/2. And if this was the case, 3 sine x would equal 1, and therefore sine x would be 1/3. So let's tackle the sine x equals negative 1/2. Now you should be familiar with your CAST diagram. If you don't use that method, then you no doubt use the graph of sine. 0 up to 1, back down to 0 to negative 1, and back up to 0. And the quadrants, there's 90 degrees, 180 degrees, 270 degrees, 360 degrees. Now you can see from this that sine is positive in the first 2 quadrants, negative, that's below the x-axis, in the 3rd and 4th quadrants. Sine's positive there and there, negative in these 2. All positive there, sine, cos, tan. Only the sine positive there, tan positive, cosine positive in these 2 quadrants. So first and second quadrant. So we'll write that down. X is in not the first 2 because that's positive. We're wanting a negative value for the sine, so that'll be 3rd or 4th quadrants. So sine x being 1/2, let's have a look at that one. We've got sine x equals 1/2. and you can do an inverse sine half in your calculator and you'll get x being 30 degrees. Now that's first quadrant, so we'll just say that down here. First quad angle is 30 degrees. So remember, if you're in the third and fourth quadrants, you use this 30 degree angle to go all the way around to 180 and add 30, and then to get the equivalent fourth quadrant you go all the way round to 360 and subtract 30. So that angles we're after, x would be equal to 180 plus 30 or 360 minus 30. If you use this diagram, you're seeing the half first, second quadrants, negative a half in the third and fourth quadrants. So you'd go 180 plus whatever the first quadrant angle is, which would be 30 degrees there. 180 plus to get this value, and then 360 minus to get this value. So whichever way you do that, we end up with 210 or 330. And we've now to tackle sine x equals 1/3. So in this case, from what we've discussed, x is in the first or second quadrants. So we do want the first quadrant angle, so let's just grab hold of our calculator. Now make sure you're in degrees, not radians, degrees, and we want the angle whose sine is, on your calculator it might be sine to the -1, it might be arc sine, on mine it's a sine, so I'm wanting the angle whose sine is 1/3, 1 divided by 3, and there's the first quadrant angle. So it's 19.47 and so on. Or, and in the second quadrant, you'd go all the way round to 180 and subtract that. So it would be 180 minus 19.47 and so on. So let's approximate this to one decimal place. Be 19.5, or, and let's work out 180 minus that answer. And that equals 160.52. 160.52 and so on. So that would be 160.5 approximately. So solutions are, let's put them in order. 19.5, 160.5, 210, 330, and these are correct to one decimal place where necessary. A couple of them are exact values, but these are correct to one decimal place. So here's question 8. It involves a graph with two curves on it, or one's a straight line, one's a curve, and we're asked to find the shaded area here. We're given the formula for the top curve, which is a cubic, and the bottom line, and we're given its formula also. And we're told where the two graphs intersect at -2 and 1 for x. So the result we're going to use is that we take the integral. In this case it will be from -2 to 1 of the top curve formula for the top curve minus the formula for the bottom curve, which is basically that straight line. And that's the strategy we'll use. So the area, let's just launch straight into it. Area is -2 to 1. That's the, we'll always work from the left to the right. Of the top curve, now the formula for the top curve is the cubic, x cubed minus 2x squared minus 4x plus 1 minus the whole of x minus 5. So that'll be minus the x and minus the -5. So that'll be a plus 5 going on there. So we can simplify this before we get into the integration. There's only that one x cubed term, one x squared term with a coefficient -2. Now there's two x terms appearing here. There's -4 minus another 1. That's -5. -5 times x. And then the constant 1 plus 5 is plus 6. So that's a little bit of simplifying before we do the integration. So off we go with this integration. And remember, we have limits, so we'll be plugging in the value -2 and the value 1 after we've done this integration. So remember, the integration, you increase the power by 1 and divide by the new power. -2 at the front, you increase the power by 1 and divide by the new power. -5 at the front, x to the 1, increase the power by 1, it'll become 2 over 2. And then 6 becomes 6x. So there's the integration. And what we now do is we put in the top value into that, that's the x equals 1, and we subtract that whole expression with x equals -2. So we've got to be very careful what we're doing here, because this -2 is going to cause us problems in a minute. So let's put in x equals 1. We can do bits of this in our head. 1 to the power 4 is 1, so our first term is 1/4. 1 cubed is 1, so this just becomes -2/3. 1 squared is just 1, this becomes -5 over 2. And 6 times 1 is just 6. Now, I would strongly advise you just to write this out without doing any working at this stage. It's because there's a negative in there, and things can go very badly wrong if we get the signs wrong. So all I'm doing just now is replacing x by -2 in each of these terms. And the last term plus 6 times -2. Okay, so let's move forward with this. I suppose 1/4 minus 10/4 would be minus 9/4. Then there's a -2/3 and there's a plus 6. Now some of these might combine with the terms left in the bracket here. So let's not do too much at once. We'll keep that negative out of the scene just now and just work out what's inside the brackets. Remember, you do have calculators, so if you're a bit confused about your ability to do mental arithmetic, you could maybe shove some of these into your calculator to check them. So -2 to the power 4, that'll give us a positive answer. So on the top line we'll have 2 times 2 times 2 times 2. Now 2 times 2 is 4. One of these two of the 2's cancel with the 4, and we're left with 4 on the top line. So as I said, 2 times 2 times 2 times 2, the 2 times 2 cancels with the 4, leaving you 2 times 2. So that becomes 4. The negative 2 cubed will be negative. With this negative, we're going to get a positive term. On the top line, 2 times 2 times 2 times 2, that gives us 16. 2, 4, 8, 16 thirds. This term, negative 2 squared, is positive, so with this negative, we get a negative term this time. 2 2s are 4, 4 5s are 20. We get 20 over 2, which is 10. And the last one is 6 times negative 2, which is negative 12. So things are progressing nicely. We've got negative 9 over 4. We've got minus 2 thirds. We've got a plus 6. Now, constants in here, we've got 4 minus 10 is negative 6, minus another 12 is negative 18. With this negative, it will be plus 18. So it just leaves us 16 over 3 with this negative outside, be negative 16 over 3. So we've got negative 9 over 4. As I say, your calculator, you can just zip through all this and work it out. However, remember, if you're in a paper 1 question, you really do need to have these skills, so you might as well practice them and enjoy them when you can, even when you're practicing paper 2. So we've got this negative 9 over 4, this negative 2 thirds, and another minus 16 thirds would be minus 18 thirds, and 3 goes into 18 6 times, so that would be negative 6. We've used this, we've used this, we've used this, so negative 2 plus another negative 16 is negative 18 thirds, cancelling by the 3, we get negative 6 for these two, and then 6 plus 18 is 24. Well, goodness, we're getting very close to the answer here. Now I'm going to write negative 9 quarters as negative 2 and 1 quarter. 4 into 9 goes 2 with 1 over, if you like, 2 and 1 quarter, and it's negative. And 6 from 24 is 18. So we're basically to take 2 and a quarter away from 18. Now if it was 2 we were taking away from 18, we'd get 16. And taking another quarter away from 16 will give us 15 and 3 quarters. Now it's the area. This area is measured in units squared. And what units squared are in a case of this would be 1 unit along and 1 unit up in that little square. That's the number that would fit into this shaded area. So here we have question 9, and in part A we're asked to express this expression, 7 cos x minus 3 sin x, in this special form. So first of all, let's remember that this special form, k sin x plus a, that can be expanded using the addition formula. Now the pattern, and you'll find this on your formula sheet, but you really should remember it, the pattern is sin cos cos sin. Now in this case, each term is multiplied by k. So let's just write all this down. We have 7 cos x minus 3 sin x, and so we're writing it like this. That'll be sin x cos a plus cos x sin a. So let's do that. Sin x degrees cos a degrees, and then plus cos x degrees times sin a degrees. So that's that pattern that you're given on your formula sheet, the addition formula. Now this k at the front means that each term gets multiplied by k. And we're trying to make this term look like this. So one of the things we can do is look in this expression and see what number is multiplying cosine of x. What is the coefficient of cosine of x? Well, it's 7. And let's look over here. There's the cosine of x. And what's its coefficient? What's multiplying the cosine of x? Well, it's slightly more complicated than the left-hand side, but let's just ring them all. There they are, lassoed in red. So 7 and k sine A must be identical, because that multiplies cos x on the left, k sine A multiplies cos x on the right. And these two expressions are supposed to be the same. Well, let's do the same with the sine x term, and you'll notice that we're multiplying it by -3. The coefficient of the sine x term is -3. Here's sine x, and multiplying sine x, we've got k times cos A. So these two coefficients must be equal, as must the coefficients of the cos x terms be equal. So let's summarise all that. Let's tackle the cos x ones first. K sine A, k sine A is equal to 7. That's the red coefficients. Let's tackle the sine x terms. K cos A is equal to -3. So there we have two, if you like, they're simultaneous equations with two unknowns. The unknowns are k and A. Now, what can we say first of all before we move forward about this angle A? Now, remember up here it says k is positive, so we know from this one that sine A must be positive because the right hand side's positive. Positive, we know, times positive must give you positive. So we can say definitely that sine A is positive. And from the second equation, we can say, since k is positive and this right hand side is negative, cosine of A must be negative. Positive times negative will give us negative. So we know that the cosine of A is negative. Now that tells us something. It tells us exactly the quadrant the angle A is in. Now there's several ways we could do this, but you possibly know the CAST diagram. We're saying sine positive. They're all positive, sine, cos, tan in the first quadrant, only the sine's positive in the second quadrant. Cosine being negative, that happens in the second quadrant, only the sine's positive, and in the third quadrant, tan's the only positive one there, and cosine's positive in the fourth quadrant. So for cosine to be negative, it's the second and third quadrants. Now for both conditions to hold, the angle A must be in the second quadrant. Between 90 and 180. So A is in second quadrant. You can also get that from looking at the graphs. Remember, there's a sine graph, the first quadrant, second quadrant, third quadrant, fourth quadrant. And you can see sine being positive first and second quadrants. It's above the x-axis there. And the cosine similarly starts out at 1, down to 0, to -1, back up to 0, and back up to 1. So there's the first quadrant, second quadrant, third quadrant, fourth quadrant. And for cosine to be negative, you can see there, second quadrant, third quadrant. The graph is below the x-axis. So definitely A degrees is in the second quadrant. So there's two procedures we carry out at this stage. And they're to do with both the well-known trig formula, connection between sine A and cos A that involves sine A divided by cos A. And that gives us the tan of A. So that's one of the well-known formulae. The other one that we're going to be using is sine squared A plus cos squared A is equal to 1. So two formulae, we'll use each of them. So to use this first one, we look at these two equations and say, well, okay, let's divide the left-hand sides so that we get sine A over cos A. So we take the left-hand side of the first equation, that's k sine A, and divide it by the left-hand side of the second equation. And that must equal the two right-hand sides divided, 7 over -3. Now if we proceed with this, the k's cancel. Sine A over cos A is tan A. Positive divided by negative is negative. So we get -7 over 3. Now the first quadrant angle, remember we're not wanting the first quadrant angle, A remember is in the second quadrant, so the first quadrant angle is, and in this case we would put positive, remember in the first quadrant the tan is positive, so we put 7 over 3 and we ask ourselves what is the angle whose tangent, now in your calculator it might be tan to the -1, it might be arc tan, on mine it's a tan, so, and I read this as what is the angle whose tan is 7 over 3. Remember we're not using the negative just now, I'm just in the first quadrant. And make sure we're in degrees, not radians. So make sure your calculator's set to degrees. And there is the angle, it's 66.80. And so on. So first quadrant angle is 66.80. Now, the one we're after, since A is in the second quadrant, and remember in second quadrant, you go all the way around to 180 and subtract the first quadrant angle. So it's 180 minus 66.80 and so on. So what does that come to? So it's 180 minus that answer. And we get 113.19 and so on. Now we'll be rounding these off shortly. So that's the value of A. Now we'll use the sine squared plus cos squared equals 1. So let's square the left-hand side of the first equation. So both terms there get squared. And let's add the square of the left-hand side of the second equation. And that's going to give us our sine squared plus cos squared. And if we've done that on the left-hand sides, we do that on the right-hand sides. So we get 7 squared plus -3 squared. common factor of k squared. That leaves us sine squared a plus cos squared a in brackets, which we know is equal to 1. So that gives us cos k squared times 1 equals, and it's 49 plus 9. So k squared is 58. And therefore k will be the square root of 58. Now normally you get a negative in there, but remember we're told k is positive, so we don't need to bother about a negative value. Now we're asked to express this in that form. Let's do that now. We're in a position to do that. So 7 cos x minus 3 sin x is equal to k, which we've worked out as root 58. We'll just leave it as that. Sine x plus a. Now I'm going to round a off. There's a, it's 113.2. And we'd better say what we've done when we vandalised that number. We've rounded it to 1 decimal place. So there's the first part of the question. So moving on to the second part of the question, part B, it says hence or otherwise find the maximum value of this expression. Now this expression is connected to 7 cos x minus 3 sin x. You'll notice it's double. Both of these terms have been doubled. So to find the maximum value, let's have a look at that one. And we'll start with 14 cos x minus 6 sin x. We'll rewrite it as twice the expression we've just been dealing with, just to show clearly that we know the connection between these, and then rewrite this in the form that we've found it to be equal to. That's root 58 sine x plus 113.2 degrees. And now that's twice root 58 sine x plus 113.2. And we're asked for the maximum value of this. Now, if it was a plain sine of an angle, you know that the maximum of a sine comes up to 1. That's when that angle is 90. So the maximum of this expression will be 1. And since we're multiplying by 2 root 58, the maximum of this will be 2 root 58. So maximum value is 2 root 58. That happens when the sine of x plus 113.2 is equal to 1. So we've achieved the maximum. And now part 2, this says, what is the value of x for which it occurs, where x lies between 0 and 360? So maximum occurs when the angle, which is x plus 113.2, well, it's 198 and so on, when that is equal to 90. Or, now there may be other, this sine curve goes on, and 90 and another 360, that's 450, would also give us a value of 1 and so on. We'll see what happens when we consider the 90. So it occurs when that angle, that's the sine's angle, is equal to 90. So that would mean that x equals Now we take 113.19 and so on away from both sides, so it's 90 minus 113.19. Now you'll notice what's happened there. This is going to give us a negative answer for x. We're very clearly told that x must lie between 0 and 360. So it's not the 90 we're going to contend with. Let's add 360 to that. So we'll get 450. So there's another value of x, and this one will lie in, 450 there. This one will lie in the range that we're asked for. Let's work out 450 minus this answer. That's 336.80. 336.80. So the value of x for which it occurs between 0 and 360, not this one, it's this one. That's a whole 360 degrees on. We have to use this 450 degree when sine reaches 1 because of the fact we're subtracting 113. That now gets us back into the range that we're after. So let's just finish this off and say x is approximately equal to 336.8, and that's accurate to 1 decimal place. Well, here's question 10, and we're asked to determine the range of values of x for which this cubic function is strictly decreasing. Now, cubic functions can look like this, or typically they have a couple of stationary points on them. Not always. You can get some that look like that, for instance. But anyway, let's examine the gradient of the graph of this function. So we differentiate it, and that will then be able to home in on these stationary points and examine the behaviour of the curve to the left or right of them and see whether the graph's going down or uphill and so on. We're interested in strictly decreasing. We're looking for negative gradients on this graph. So we need to differentiate first of all to get the gradient formula. So we've got 2x cubed plus 9x squared minus 24x plus 6. So let's differentiate that. Here's the gradient formula. It's now going to appear 3 times the 2, x squared. Take 1 away from the power. 2 times the 9. Take 1 away from the power. And this term will just have a negative 24. That term will become 0. So there it is. Let's just take out the common factor of 6 out of that. Now, for stationary points, for homing in on the points where the gradient is 0, for stationary points, we'd set that formula, gradient formula, equal to 0. So 6 lots of x squared plus 3x minus 4 equals 0. Let's hope it factorises. No choice for the firsts. Now the lasts, 4 times 1 is going to be a suitable one. The outsides give us 1x, the insides give us 4x, and to get a positive 3x, we'd add the 4x, take away the 1x. So positive 4x minus 1x. So for this to be 0, either one or other of these two terms would be 0. So x plus 4 equals 0, or x minus 1 equals 0. If this was the case, x would be negative 4. If this was the case, x would be 1. Now we'll need to decide what's going on at the point negative 4. So we go a wee bit to the left, a wee bit to the right, and see what's happening. So that's our x value. We'll look at the gradient. Now remember, the gradient formula is this. Forget about the 0, it's this. 6 times that times that. And if we go slightly to the left of negative 4, let's go to negative 5. This term would be negative. This term is negative. The product of these would be positive. We know it's 0 at negative 4. If we go slightly to the right of negative 4, not as far as beyond 1, then let's go to negative 3. That would be positive. Putting negative 3 in there, this is negative. Positive times negative is negative. Of course, the 6 doesn't involve itself, it's just positive. So there's the nature of the slope round about this stationary point. So it's going uphill and then downhill. So it's increasing, stationary, then decreasing. And it's the decreasing ones we're after. Let's do the same sort of analysis for x equals 1. We'll go a little bit to the left, a little bit to the right. That's our x values. And let's look at the gradient. So a little bit to the left of 1, let's just go to 0. 0 plus 4 is positive, 0 minus 1 is negative. When you multiply these, you get a negative answer times that. Positive 6, still negative. When x is 1, gradient 0. Just a bit to the right of 1, say 2. This is positive, 2 plus 4. This is positive, 2 minus 1. So what do we know about the shape in this case? Well, it's decreasing, stationary, then it's increasing. So we can see that we must be in a situation like this curve where we're stationary point at negative 4, stationary point at 1, and in between we've got a strictly decreasing graph. So f of x is strictly decreasing for x lying between negative 4 and 1. Now we cannot have equal signs there, otherwise it's stationary when x is negative 4 and it's stationary when x is 1, and that's certainly not decreasing. So that's the required range of values. So here's question 11, and we're told the information about two circles, C1 and C2, and this is their equations. We're asked to calculate the distance between, in part A, the distance between the centres of C1 and C2. So let's have a look at what information we can glean from, for instance, this equation for circle 1. Now I mean by information the centre and the radius. These are the two vital pieces of information before we know all about the circle. Now you are given this information about the formulae in two different forms of a circle and how you can work out the centres and the radius. So this is the second form that we're dealing with, and we'll notice that the x-coordinate of the centre A can be got from this equation by looking at the x term that you're squaring and the constant and changing the sign. So that constant is negative 4, we change its sign. So the centre of this circle would have an x-coordinate of positive 4. X term squared, go to the constant, change the sign. That gives you your x-coordinate of the centre. Similarly, the y coordinate of the centre is got from the y term that you're squaring, the constant term, change the sign. The constant term is 2, change the sign, -2. So there's the centre of circle 1. Now let's, at the same time, let's have a look at its radius. And we're told in this form that this number here is the square of the radius. The radius is r, this number is r squared. In other words, 37 is the radius squared. To get rid of a square, we do the opposite, which is square rooting. So the radius is equal to square root of 37. Let's have a look at the second equation, the circle C2, and we'll notice that it's in a different form. That's the one that involves all these 2g's and 2f's. Now there's several ways of tackling this, but this form is really this first form with the brackets squared out. We could really undo this and get back to this squared form. If we isolate the x terms and the y terms and the constant, then we can say, what did we square to get x squared plus 2x? Well, half this, x plus 1. And remember multiplying out something like x plus 1 times x plus 1, do your firsts, outsides, insides last. X squared, outsides x, inside pair gives you an x, that's the 2x, but the lasts give you a 1. We never had that, so let's take that away. Similarly for the y, be y and then half this to get -3. And let's just check that. The firsts give us y squared, outside 2 give us -3y, inside 2 give us -3y. That deals with the -6y. The lasts give us +9. We don't want a +9, take it away. And we've got the -7 tucked away at the end there. So we're almost there. x plus 1 all squared, y -3 all squared, -1 minus 9 is -10, -7 is -17 on the left, add 17 to both sides, and we end up with this. And we can immediately say that the centre, just like we did in the first case, the centre is change sign, -1 for the x coordinate, change sign, -3 becomes 3 for the y coordinate. And the radius, well, 17 is the radius squared, so the square root of 17. So that's the information we've got, and we're asked in part A to calculate the distance between the centres of C1 and C2. Now, there is a formula called the distance formula. You might have learnt it using an x1, y1 and an x2, y2. If these are points A and B, the distance formula tells you the distance is got by square rooting the x difference squared plus the y difference squared. That's the difference of the two x coordinates and the difference of the two y coordinates. So let's do that. Distance d between centres is the square root of the x difference squared. Let's look at that. Now, there are the two centres. 4 minus -1 plus the y difference squared, -2 minus 3. Now, 4 take away -1 is 5. 5 squared is 25. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. So we've got 25 plus 25. That's root 50. So the distance d between the two centres is root 50. Part B says, hence, show that C1 and C2 intersect at two distinct points. Now, the hence means you must use the information that you calculated in Part A, this distance between the centres. And we've to use that to show that the two circles, C1 and C2, intersect at two distinct points. Now, if you're given two circles, there are basically three different situations that arise. In this case, they don't intersect at all. In this case, they touch, so there's one point of intersection. In this case, they overlap, and there's two distinct points of intersection. Now, if this is the distance d between the two centres, then in this last case, suppose we call this radius 1 and this radius 2, you can see quite clearly that if you add up the two lengths r1 and r2, there's a wee gap. You'll get a number that's smaller than the total distance between the two centres. So if they don't intersect, then we can see that r1 plus r2 is a smaller number than the distance between the centres. r1 plus r2 is less than d. In this case, I think you'll agree that if you add up the two radii, you'll end up with exactly the distance between the two centres. So r1 plus r2 equals d, in this case where they touch. And in this last case, if we add up r1 and r2, you can see these two distances overlap. So when we add them up, we'll get a larger number than the distance between the two centres. So we have to show in this question that this is the situation we're dealing with. So let's have a look at this. Let's call this radius r1 and this radius r2. Well, let's consider r1 plus r2. Well, that's root 37 plus root 17. And d is root 50. So we've to show that r1 plus r2, this number, root 37 plus root 17, is greater than root 50. Now, we do have access to calculators, so why wouldn't we use that? So what is r1 plus r2? It's the square root of 37 plus the square root of 17. That's 10.20 and so on. And what's the distance between the centres? Root 50, square root of 50, 7.07, and so on. So it now becomes clear that in this case, r1 plus r2, that's our 10.20 and so on, is a greater number than d, which is 7.07 and so on. So r1 plus r2 is greater than d, and the two circles intersect. Now that's this case here. They intersect at two distinct points as required. So here's question 12, and we're told for a curve that its gradient formula dy by dx is 8x cubed plus 3, and that it passes through the point negative 1, 3. And we have to express y in terms of x. Now, if we have y and we travel towards dy by dx, well, you know what that's called. That's differentiating. But this question involves the reverse, the inverse process. We start off with dy by dx and we end up with y. And the inverse process to differentiate is, or differentiation is, integrate. That's the process. We need to integrate. Integration is the inverse process to differentiation. So let's at least do that. So dy by dx is equal to 8x cubed plus 3. Therefore, y will be equal to the integral of 8x cubed plus 3. And integrating, we increase the power by 1 and divide by that new power. And remember, the 8 is just in the audience watching all that happening. 3 becomes 3x. Remember to check that, you can differentiate back. If you differentiate 3x, you get 3. So that is our answer to integrating that expression. But remember, plus c. Remember, if you differentiate a constant, it vanishes. So any of these curves, and there's loads of them, y equals, and 4 goes in there, 4 goes in there. So 2x to the power 4 plus 3x plus c. So there's a whole load of curves. This plus 1 plus 2 plus 0.5 minus 26 and so on at the end. There's masses of curves. To pick the one we want, we need to use this information. So there's one particular curve that passes through the point negative 1, 3, and therefore we can home in on finding the value of c. Now this, let's write this down, that this curve passes through negative 1, 3. And what does that mean? Well, when x is negative 1, y is equal to 3. So we know that point's on the curve, therefore these values for x and y will work in this curve. So let's try that. That implies that 3, this y here, will be equal to 2 times negative 1 for x to the power 4 plus 3 times negative 1 plus the constant. So we can find this constant because we can work all this out. So let's see what we're going to get. 3 equals, now negative 1 to the power 4, that's 4 negative 1's multiplied together. The answer will be positive. Times 2 is just 2, so it's 2 times 1, which is 2. And this is negative 3 plus c. Now 2 minus 3 is negative 1, add 1 to both sides, we'll get 4 equals c. Right at the normal way round, c equals 4. So express y in terms of x, no problem. Y must be equal to 2x to the power 4 plus 3x plus 4. So that's the one particular curve out of this whole family of curves that passes through this point negative 1, 3. So here's question 13, and we're given a formula that allows us to calculate the concentration of a medicine in a patient's blood after a certain length of time. Here it is, and we notice it's got the exponential function e to the power x in there. this case it's not x, it's a more complicated expression involving t. So we're asked in part A to use this formula to calculate the concentration of the medicine after 30 minutes. Once the dose was given 30 minutes later, what is the concentration? The concentration is measured in milligrams per litre. So in this case we're asked to find the concentration. We know the time. So we must substitute t equals 30 into this formula to find what C of 30 is. What is the concentration after 30 minutes? So it's 11 times e to the negative 0.0053 times t, and we know we're substituting 30 for t. So there we go. And calculator at this stage would do that calculation in a winner. So let's attempt to do that. We have 11. We're multiplying it by, now on your calculator you should have an e to the power x button. That's the one you want to use, e raised to the power of, in this case it's a negative number, so I'm using the negative key, 0.005, 3, and we're multiplying that by 30. We're making sure that the whole of the power that we're raising e to is in brackets, and there's a negative in there. So that gives us this answer, 9.38 and so on. So approximately be 9.4, and it was measured, let's get rid of that. The measurement is in milligrams per litre, and we've measured that to 1 decimal place. So that's our first part of the question. Let's have a look at the second part. This asks us to calculate the time taken for this dose of medicine to become ineffective, and concentration of 0.66 milligrams per litre is considered to be ineffective. So this time we know the concentration, and we're attempting to work out the length of time that lapses before that concentration is achieved. So that's our first piece of information. Let's substitute that now into this formula. So this time we don't know the concentration, that's what we're attempting to find, and there's the rest of the formula. So let's, as we said, substitute 0.66 for the concentration, 11 times e to the negative 0.0053t. Now, to try and get t on its own, let's see what we can do. We'll divide both sides by 11. Now, 11 into 0.66, if you try that in your calculator, you'll get 0.06, and 11 into this, 11 cancels, and that's what we're left with. Now, this looks like a healthy power statement. For instance, 100 equals 10 squared. That's a power statement, and every power statement we can change into a log statement. And in this simpler case, the base is 10. This is the log up here. Log to the base 10 of this number 100 is 2. That's how we'd write this as a log statement. Log to the base 10 of the number 100 is 2. What power do you raise 10 to get 100? The answer's 2. So that keep in mind when we're doing this. So let's follow the pattern. The base here is this 10. So the base in this case will be e, log to the base e. This number is this 100, which in this case is 0.06, and that would be equal to the power here, the 2 in this case, which is this negative 0.0053t. So let's put that at the front. Because we remember we're trying to find t, so let's divide both sides by negative 0.0053, and we'll get log to the base e 0.06 divided by, now it's a negative, the whole thing will be negative, and there's your 0.0053. So this is the calculation we're going to have to do to work out t, and again that's one that we can do on our calculator. So the whole answer is negative, there it is. On the top of the fraction we've got log to the base e, now that's sometimes called the natural log, and on this calculator log, L-O-G, is to the base 10, log to the base e is this ln key. On some calculators it looks like in, but it's ln. So that's log to the base e button. So that's what we're trying to find for 0.06. And then we have to divide by 0.0053. And there's our answer. It's positive 530.83 and so on. Now that's the time that elapsed, so required time is, we'll say 531 minutes to nearest minute if I round it off. Well, you may want to be more practical and give it in hours and minutes. Remember, 60 minutes in an hour, 6 eighths are 48, so it would be 6 hours. That gives you 480 minutes, and that leaves 51 minutes left over. So either of these two. So here we have question 14. We've got an open box. There's its net. It's the shape of a cuboid with various measurements given. And in part A we have to express the area of that net in terms of h and x. So that's the first part of A. So let's have a look at how this would fold up into an open-topped cuboid. So there it is, and that base, there's the base, appears here, and we've got, let's call this the back. That would correspond to this, so that's been folded up, and then these two fold round to get the sides, so that's the left side, and this is the right side. That's the left side, and this is right side, and then this therefore folds all the way around and becomes the front of that open topped box. So that's the front, and the dimensions were given. The height is h, the base has length 3x, and this breadth is 2x. So there's the 3 dimensions of that box. So to find the area of that net, we'll add up all the various parts. There's going to be the base, there's going to be a left side, and there's going to be a right side, and there's going to be a back and a front. So let's work our way through these. So they're using the letter A for that area. So the base, first of all, 2x times 3x, that's 6x squared. Left side and right side. Now the left side, 2x times h, 2xh, identical, another 2xh at the other side, so that'll be 4xh. And then the back and the front are identical, and that would be 3x times the height. That's that area, 3x times the height. So that's 6xh, 3xh plus another 3xh. Now we can simplify this by adding the two like terms there. A 4xh plus a 6xh is 10xh. So that's our formula for the area. So that's part A, first part of A. Now let's move on to the second part of A, and it's telling us that that area that we've just worked out is 7,200 square centimetres, and we're asked to show the volume of the box is given by this expression. Now if we look closely at this expression, there's no mention of h, it's all in terms of x. So let's start with the formula for the volume of this box, and that would be length times breadth times height. So it's a 2x times a 3x times a height, and that'll give us 6x squared h. Now that volume involves the letter h, so we have to replace h by an expression that's got nothing but x's in it. And that's where this information that we're given, that the area of that net is 7,200 square centimetres, because we do have an expression for that area. So 6x squared plus 10xh, the area of that net is given by 7,200. Now let's solve that for h and try and get h on its own. So 10xh will take 6x squared away from both sides, and then divide both sides by 10x. So we're going to get h on its own. Now each of these terms will be divided by 10x, so we'll have 7,200 divided by 10x minus 6x squared divided by 10x. And that can be simplified somewhat. 10 into 7,200 goes 720, and we're left just with the x. So we're cancelled the factor of 10 top and bottom here. Now the bit of cancelling goes on here. One of these x's cancels. Top line we've got an x times an x. One of them cancels with the x at the bottom, leaving just an x. And then the 6 and the 10 would become 3 over 5 when we cancel by 2. So we'll get 3x over 5 for the second term. And we've achieved what we were after, an expression for h involving just x. So we can replace that in the expression for the volume. We knew the volume is 6x squared times the height. We now know the height is 720 over x minus 3x over 5. Now let's see what happens when this is multiplied out. So 6x squared times 720 over x, one of these x's cancels, leaving you 1x. 6 lots of 720 is 4,320. You check that on your calculator, of course. So that's 4,320 with an x there. Second term, 6x squared times this will be negative, and on the top of the fraction, 6 3s are 18. X squared times x is x cubed, and we've still got a 5 at the bottom of the fraction. Now, fortunately, this is exactly what we were trying to show. So that's part 2 completed. Let's now have a look at part B. And it says determine the value of x that maximises the volume of the box. So we have so far achieved an expression for the volume of the box that just involves x. It's a function of x. And if we're trying to find maximum values, think of the graph of the volume. We would be looking for a maximum stationary point. In other words, when the gradient on the graph is equal to 0. So we're going to have to differentiate and discover the stationary points on this graph. So let's do this for stationary points. We'll set v dashed of x equal to 0. So let's differentiate this expression. It's our first task. So 4,320 times x will become 4,320. And we've got 18 over 5 times x cubed. So we bring the power down to the front and multiply. So 18 over 5, let's do it here. 18 over 5 gets multiplied by 3. And there's no cancelling. We have 3 times 18, which is 54. X squared over 5. So that's the expression for the gradient. And so if we're finding stationary points, we set that expression equal to 0. So 4,320 minus 54x squared over 5 equals 0. So let's add 54x squared over 5 to both sides. That'll appear over here, equaling 4320. So we know that 54 times x squared over 5 will equal 4,320. Let's continue. We'll multiply both sides by 5 and divide both sides by 54 to get 1x squared. So the right hand side gets multiplied by 5 and divided by 54. And to get x, let's take the square root. So what is the square root of that? Well, we might as well use our calculator because we're in paper 2. So we'll take the square root of 5 times 4320 divided by 54. That gives us 20. Now, you'll notice we don't need a negative value. X is bound to be positive because x involves lengths. Twice x for this width or length of this box would not make sense if it was negative. So x has to be positive. So x equals 20. Now what is the nature of this point? Is it a maximum? Does it maximise the volume, or is it a minimum? Well, the way we do that is make up the wee nature table, as it's called, and go slightly to the left of 20, slightly to the right of 20, and examine what's happening to the gradient on either side. I mean, we know certainly that when x is 20, the gradient is 0. Now, if we hunt down the gradient formula here, there it is. Let's just circle that in red so that we can refer to it easily. So, if we go slightly to the left of 20, if we had 19 for instance, remember when x is 20, when we work this term out, we get exactly 4,320 to get that 0. 4320 minus 4320, that'll give us 0 when x is 20. So if we reduce x, say, to 19 squared, the number we're subtracting from 4320 will be less than 4320, and we'll get a positive value. If we do the same argument when x is 21, for instance, when x is 21, this number that we're subtracting from 4320 will be greater than 4320, so we'll end up with a negative value in there. So we can now determine the shape of that graph around about the value x equals 20. It's increasing, stationary there, and decreasing. So what can we say? We can say that x equals 20 does give a maximum value for the volume. It maximizes the volume. Well, here's question 15. Diagram shows that we have a circle and a tangent that touches at the point 2, 5. Now we're told the equation of that tangent, and we're also told that the centre of this circle lies on the y-axis. Our aim here is to find the coordinates of that centre. So let's have a look at a working diagram, and we'll use that information that the centre of the circle lies on the y-axis. So let's draw in the y-axis there. Now that would mean that we know the x coordinate of that centre point is 0, and we're asked to find basically the y coordinate. Now you'll notice in this diagram that from the centre to the point of contact, that radius, let me just draw that in, that radius we know, or we should know, is perpendicular to that tangent. So the strategy therefore would be to examine this line that contains this radius. Basically, if we work out the equation of that line, we can plug in x equals 0 and out should pop the y coordinate. So we'll aim to get the equation of this line that contains that radius. So first of all, to find the equation of a line, we need to know the gradient, and we need to know a point on that line, and our usual formula, y minus b equals mx minus a. You might know this using the point x1, y1, but that gives us the equation that we're after. So we would have to find the gradient of this line. We already know a point that's on it, 2, 5 we know. And the gradient of this line that contains the radius is related to the gradient of the tangent, because the tangent is perpendicular to that line containing the radius. Remember, there's a result that says a gradient times the gradient of a perpendicular line will give you -1. In other words, to find the perpendicular gradient, let's divide both sides by m. We turn m upside down, invert it, and change the sign. So let's try to find, first of all, the gradient of the tangent. So gradient of tangent. And the way this equation is given to us, it's not in a form we can easily work out the gradient. Usually, if it's in the form y equals mx plus c, the coefficient of x tells us, the number in front of x tells us what the gradient is. So let's rearrange this equation into this form. So we'll get y on the left. Let's get rid of x. So we have 3y. Take x from both sides. We get -x plus 17. And then divide both sides by 3 to get rid of that 3 there. So both terms get divided by 3. Now, the expression x over 3 is exactly the same as 1/3 x. If you divide a number by 3, it's the same as multiplying it by 1/3. So these two expressions are the same. So basically we've got y equals -1/3 multiplying x, and we've got 17 over 3 at the end there. So that implies that the gradient of the tangent is -1/3. So it's a gently sloping downhill graph, 3 along, 1 down, 3 along, 1 down. That's what -1/3 gradient means. So therefore the perpendicular gradient, that's using this product being -1, what number times -1/3 will give you -1. Invert the third to become 3 over 1 and change the sign. So we get a gradient of 3. Now check, does that radius have a gradient of 3? 1 along, 3 up, 1 along, 3 up. It looks reasonable. So that's the gradient of the perpendicular, that line there. So the equation of the radius, this line, well, what do we know? We know the gradient of that radius is 3, and we know a point on the radius is the one that we were given, 2, 5. So we're now at the stage where we can use this formula to find the equation. So the equation is y minus b, that's the y coordinate of the point on the line, equals gradient, which we know is 3, times x minus the x coordinate of the point, which is on the line. And let's get rid of brackets. Got y minus 5 equals 3x minus 6. Let's add 5 to both sides. That -5 will disappear, and we get 5 added to -6 is -1. So we've now got the equation of this line that contains that radius being y equals 3x minus 1. And when x equals 0, y therefore is -1. The centre has coordinates 0, -1. And you remember y equals mx plus c. This constant c at the end is where a line crosses the y-axis. So it crosses at -1, which is what we've got in this diagram. So let's just answer the question. Centre is 0, -1. That's Mr. Corsi signing out. Hope you enjoyed the video.